Welcome back. So today we are going to again continue our discussion on spatial transformation, lecture number 7. Um, as you know, we are discussing when a rigid body is rotating about inertial coordinate frame or body coordinate frame, as the case may be, how the rotation can be described in the form of matrix, that is mathematical description of orientation, which we are focusing on. Okay. These are actually in the past lectures we introduced you. This is the rotation matrix. From very fundamental we got this. Also, it will be a good exercise for you if you try to do this. Okay, that means starting from PU, PV, PW from very fundamental, you can deduce what will be this relation as well. Okay, and tell me the nature between this matrix and our matrix R. Okay, so this will be an interesting thing to observe. Okay, and we will discuss that R prime and R has very interesting relation. Okay, which is characteristic feature of orthogonal transformation. Meanwhile, the transformation which we are studying is called orthogonal transformation because our axes are orthogonal, and about any of the axis the rotation is taking place. Okay. Now let us see. I tried so that it might help to use a color code. Red means body coordinate frame and black, of course, inertial coordinate frame. So we will now try to deduce from this main or mother matrix R. We can you tell me that what will be the nature of the matrix when the body has undergone a rotation about x-axis by an amount theta. Okay. Now to do this, first I suggest that you draw the coordinate axis, which is very important. Always you do that. Okay. This is x, this is our y, this is z, and this is ix, jv, jy, and kz. Okay, kz, and then as you know by definition, now when you are rotating about x-axis, okay, the body will undergo a rotation, and together with that some coordinate axis will actually flip. Let us draw and then I will explain. This is your u, okay, and iu is the unit vector along u, and this is your v, and unit vector along this axis was jv. Okay, better unit vector I can write here. Okay, jv, and this is this is sorry about that. Let me try one thing. So this is the axis. Okay, this is your W and KW unit vector along this axis. Now what has happened actually when you when the body has rotated by an angle theta about x-axis, that means if I keep my eyes here, then this make the body has undergone a rotation theta, because we assume this is a convention that anti-clockwise direction is positive, clockwise direction negative. Theta we are assuming it is positive because plus sign is there. It hardly matters, but convention is when I am looking from here, this should be anti-clockwise. And you see Ix and Iu, U and X are still overlapping, and V has flipped from Y and W has flipped from Z. Okay, and this angle is theta. This angle is theta. This is orthogonal transformation. Okay, this angle is theta. Now, under this backdrop, one thing you must understand, that here the rotation is taking place. This is our YZ plane. This is a YZ plane, and x axis is perpendicular to this plane. Okay, this is perpendicular to the plane, and this W, Z, V and Y, they are all in X, they are all in Y, Z plane, okay, on this plane. Okay. If you understand this, then everything is very simple. So, this is Y, Z plane, and all the axes Y, V, Z, W are on this plane, and X and U are perpendicular to this plane. That means angle between X and V 90 degree, although it does not look in this figure, but it is a 3D geometry. Angle between X and Y are 90 degree, angle between X and Z obviously 90 degree, angle between X and W also 90 degree, because these axes are on YZ plane. I hope it is clear now. And with this, let us try to evaluate this matrix. So, you see, this matrix, what will be the nature of the matrix? Try to understand. IU dot Ix, the angle between them is 0. So, this will be 1 cos, and these are unit vector 1, 1, and angle between them is 0. So, the value is 1. Then IXJV, as I told, that since they are 90 degree, this will be 0. Similarly, this will be 0. By the same reason, this will be 0. And by the same reason, KZIU also will be 0. Okay, and then the angle, you see JY and JV. JY is here vector, okay, and JV is here vector, and angle between them is theta. So, this will be simply cosine theta. Okay, and then JY KW, JY is here and KW. So, this is actually pi by 2 plus theta, that is 90 plus theta. So, minus sin theta, clear. And then you see KZ JV, KZ is here, JV is here. So, this is the angle 90 minus theta, cos 90 minus theta is sin theta, and then KZ dot KW, angle between them is theta. So, cosine theta. So, this is the rotation matrix or when you are rotating the object by x axis, about x axis by an angle theta. Similarly, can you derive now? We can derive also y, say, by an angle phi. What will be the nature of the matrix? Okay. So, again I suggest you will have to draw let us draw the figure. And see whether you can do it. X, Y, Z. This is Ix unit vector along this axis. JV, JY, and KZ. These are the unit vectors. And then so now the rotation is taking place about about y axis. Okay, so the which axis will be completely aligned with y? Obviously v. Okay, and okay, let me redraw. This is v, and JV is the unit vector along this axis. Okay, and this is our W KW, and now U IU. So now U and X will be flipped, and then Y and V, they are overlapping axis. Okay, because rotation has now taken place about Y axis. Okay, so try to understand, and let us try to see what is the quantum of the rotation. This is phi, so this angle is also phi, and that is exactly what we are drawing. So you are seeing from here, so this is actually counterclockwise rotation, this is phi, anticlockwise, seeing from here. Okay, so now once you draw this figure correctly, everything else is very, very simple. Okay, so then it will just, you'll have to reevaluate this matrix R. Okay, so R Y phi will be equals to, just reevaluate this matrix. Okay, Ix Iu, so this is actually cos phi. Okay, Ix JV. Now you see all the axes Z, W, X and U, they are on actually on this plane. On this YZ plane, XZ plane. Okay, XZ plane. So XZ plane. This was your YZ plane. So all these axes are on this plane, and Y is perpendicular to this plane. Y is perpendicular, Y and V are perpendicular to this plane. Now accordingly, now you can see that this will be again 0, because angle between them is actually 90 degree, and then Ix KW, Ix is here, KW is here, so it will be Ix is here, KW, so cos of pi by 2 minus phi, that means sin phi. Okay, and then JY IU, again angle between them is 90 degree, angle between them is 0. This also angle between them is 90 degree. And then kz iu, kz, this is kz and iu. Okay, so this is cos of pi by 2 plus phi, that means minus sin phi, minus sin phi, and this is again 0, and this is cos phi. Okay, very easy. So this is the matrix. Now it will be good for you to also check what will be the matrix. Again redraw. This is X, Y, Z, this is Ix, Jy, K, Z, okay, and the about Z axis, so Z and sorry. Okay, so this is, sorry about that, this is W and along this is KW, and you are rotating about Z axis, so this is U, this is V, this is IU, JV, okay, and now this is your flipping will be done in this plane, okay. This is XY plane, and to this plane Z is perpendicular, okay. So now we are giving rotation about this axis. This is your psi, and then under this backdrop the matrix will be, or Z psi will be equals to just this is the same matrix again. You will have to, this is the matrix which we will have to evaluate, okay. Then IXIU, this angle, this is the angle which is psi, this is the angle which is psi, okay. So this is the angle psi, so angle between them is, so this will be cos psi, okay, and then this is an Ix JV, Ix and JV. So cos of 90 plus psi, cos of 90 plus psi means minus sin psi, and then Ix KW, this is of course 0 because angle between them is 90 degree. Then Jy IU, Jy and IU, cos of pi by 2 minus psi means sin psi, okay, and then it will be again Jy JV, okay, this is cos psi, isn't it? The angle between them is psi, and then again this is 0, and please check because now Z is perpendicular to the plane, XY plane, these elements will be 0 because angle between the dot product of the unit vectors are 90 degree, okay, and kz ky are superimposing, okay, angle between them is 0, so this is 1. So these are the three fundamental matrices which can be derived from the same matrix, and these three matrices represent the three principal operation which a rigid body is undergoing, and then these are the matrices. One thing I should suggest you to observe, okay, you don't have to remember, but if you observe, when you are giving rotation about x axis, so x is 1, row wise, column wise, all elements are 0, and then sine, then cosine, minus sine, sine, cosine. Then again about y, when you are giving, see, diagonal wise, y is now 1, and then all row and column, all elements are 0 except this y, okay, and then cos, sine, sine, cos, okay. So, and then again, if this is diagonal, z is 1, all other elements along row and column are 0, and then cosine, sine, cos. So they have some kind of remembering rhythm, okay, because these matrices are very, very important, and perhaps you have also seen in graphics similar kind of principal matrices. And now, when a number of transformation will be given, how the things will be represented, we will discuss in our next class. Till then, stay safe. Goodbye.